Hey everyone, welcome back to Math with Mr. DJ. I'm so glad you're here today. We're diving into one of my favorite topics in math, divisibility. And here's the cool thing. Once you understand divisibility, you can do some seriously impressive mental math. So stick around. Let's figure out how to tell if a number can be divided evenly without actually doing the division. Imagine you're at a party with 4,536 cookies. Yeah, I know, that's a lot of cookies, but just hear me out. Okay, you need to divide them equally among your friends. But here's the thing, you don't know how many friends are coming. So, what if you could instantly know whether those cookies could be split evenly into groups of 2, 3, 4, 5, 6, 8, 9, or 10 without doing any actual division? See, that's the power of divisibility rules. And today we're going to learn them all. Divisibility rules are shortcuts that tell us whether a number can be divided evenly by another number. They're not magic. They're based on patterns in our number system. Let me show you each one and explain why they work. Divisibility by 2. The rule is simple. A number is divisible by 2 if its last digit is even. 0, 2, 4, 6, or 8. Why does this work? Because our number system is based on powers of 10, and 10 is divisible by 2. So every place value except the ones place is already divisible by 2. That means we only need to check the last digit. If the last digit is even, the whole number is even. Divisibility by 3. Now, this one's a little bit trickier, but it's cool. A number is divisible by 3 if the sum of its digits is divisible by 3. For example, the number 234. 2 plus 3 plus 4 equals 9. And 9 is divisible by 3, so 234 must also be divisible by 3. It's really cool. Divisibility by 4. A number is divisible by 4 if its last two digits form a number that's divisible by 4. Why does this work? Because 100 is divisible by 4, and so is every higher place value, 1,000, 10,000, etc. So all those place values are already divisible by 4, and we only need to check the last two digits. For example, to check if 3,524 is divisible by 4, we only look at the 24, the 2, the 4 at the end. Since 24 divided by 4 equals 6, the whole number, 3,524, has to be divisible by 4 as well. Divisibility by 5. A number is divisible by 5 if it ends in 0 or 5. Think about it. We count by 5s. 5, 10, 15, 20, 25, 30. Those all end in 5 or 0. And here's why. Because 10 is divisible by 5, and 10 is our base unit. So every tens place, hundreds place, thousands place, they're all divisible by 5. So again, you only need to check the last digit, and if it ends in 0 or 5, then it's divisible by 5. Divisibility by 6. A number is divisible by 6 if it's divisible by both 2 and 3. Why? Because 6 equals 2 times 3, and 2 and 3 are both prime numbers. So for a number to be divisible by 6, it must have both 2 and 3 as factors. This means the number must be even, divisible by 2, and the sum of its digits must be divisible by 3. For example, 144 is divisible by 6 because it's even, and 1 plus 4 plus 4 equals 9, which is divisible by 3. Divisibility by 8. A number is divisible by 8 if its last three digits form a number that's divisible by 8. Why? Well, because 1,000 is divisible by 8, and so is every higher place value. So all of those place values are already divisible by 8, and we only need to check the last three digits. For example, to check if 45,128 is divisible by 8, we only look at the 128, the 1, 2, 8 at the end. Since 128 divided by 8 equals 16, the whole number, 45,128, is divisible by 8. And also, don't forget, if it ends in 000, that is also divisible by 8 because 1,000 is divisible by 8. Divisibility by 9. A number is divisible by 9 if the sum of its digits is divisible by 9. This works for almost the same reason as the divisibility by 3 rule, but with a twist. When you divide any power of 10 by 9, you also get a remainder of 1. So, to figure out if a number is divisible by 9, you just add up the sum of the digits And if that's divisible by 9, then the whole number is also divisible by 9. Divisibility by 10. A number is divisible by 10 if it ends in 0. This one's obvious when you think about it. 10 is our base number, so any number that ends in 0 is a multiple of 10. It's literally how we count by tens. 10, 20, 30, 40, 50, so on and so forth. So if it ends in 0, then it's divisible by 10. Let's do an example problem. Let's test if 4,536 for divisibility by 2, 3, 4, 5, 6, 8, 9, and 10. All right, let's work through here step by step. Now, divisibility by 2. Look at the last digit, 6. Is 6 even? Yes. So 4,536 is divisible by 2. We could write 4,536 divided by 2 equals 2,268. So it's divisible by 2. Okay. 3. Divisibility by 3. Let's add up the digits. 4 plus 5 plus 3 plus 6 equals 18. Is 18 divisible by 3? Yes. 18 divided by 3 equals 6. So 4,536 is divisible by 3. Divisibility by 4. Let's just look at the last two digits. 36. 36 divided by 4 equals 9. So yes, 4,536 is also divisible by 4. Let's look divisibility by 5. Does it end in 0 or 5? No, it ends in 6. So it's not divisible by 5. Divisibility by 6. Did divisibility rule for 2 and 3 work out? Yes, it did. So this number also has to be divisible by 6. 4,536 is divisible by 6 because it's also divisible by 2 and 3. Divisibility by 8. You look at the last three digits. 536. That's divisible by 8. 536 divided by 8 is 67. Divisibility by 9. Well, we already found that the sum of the digits is 18 when we were doing the divisibility rule of 3. So is 18 divisible by 9? Yes. 18 divided by 9 equals 2. So 4,536 is divisible by 9. What about divisibility by 10? Does it end in 0? No, the last digit is 6. So 4,536 is not divisible by 10.